Hello, my name is Kaya Mitchell, and today I'll be presenting Lab 4 for Physics 2211. The objective of this lab is to use the energy principle to observe the kinetic and potential energy of a spring mass system that oscillates in the y direction and also predict its motion using Newton's second law. Elastic potential energy is associated with the force exerted by an elastic mass, which is equal to the work done to stretch the spring as it relates to the spring constant k and the distance it travels. In this lab, the mass oscillates in the y direction, which means that the spring mass system also has stored gravitational potential energy as a result of this vertical position, which will also be used to predict the object's motion. After completing this lab, the results showed that the computational model is able to successfully predict and model the motion and position of a spring mass system. It also successfully graphs the energy stored in the system and shows that it can change as the object oscillates through different y positions. So here are some of the physical principles used within this lab. Here are the forces that will be used to update both the momentum and velocity of the system, which is the spring and gravitational force. We then use the conservation of energy, or the energy principle, where we set the total energy equal to 0, making it a closed system. Therefore, the only energy acting in the system is the kinetic energy and the potential energy, which is represented by the gravitational potential and elastic potential energy. I then use the momentum principle to update the momentum, velocity, and position of the spring mass object as it oscillates. So for the computational model, we first had to start off by setting initial conditions, where the mass was given to us to be 0.402 kilograms. The initial position vector was found using the data from Tracker, and we set the velocity equal to 0, being that it's released from rest. I found the spring stiffness to be 6.36 newtons per meter, and the relaxed spring length was given to us in the video, which was 0.123 meters. And these values were plugged into the data. Plugged into the computational model. Going on, we then apply Newton's second law by updating the velocity and position of the ball, where the forces were gravity that acts in the negative y direction and the spring force that acts in the x and y direction, and together these make up the net force, and we use this to update the ball's velocity and then the position. We then apply the energy principle in order to graph the kinetic, gravitational, and spring potential energy. And right here we have that the kinetic energy is equal to 1/2 mass times velocity squared, and we found the change in gravitational potential by multiplying the ball times force of gravity and change in y position. And then for the elastic potential, we have 1/2 k sub s squared, and together the kinetic and potential energies make up the total energy, which will all be equal to 0. So here are my results. So for the change in energy versus time graph, we have the kinetic energy represented in blue, the spring potential represented in green, the gravitational potential represented in red, and the total energy represented in orange. And we found that this computational model successfully graphed the energy that is stored in the system as the system oscillates through its motion. And then here's a position versus time graph, where the red represents the real-time motion and the blue represents the computational model of the motion. And with this graph, we found that so you see that over time the graph has like discrepancies, and we found that non-conservative forces such as air resistance that aren't accounted for in the computer model have small effects that slowly add up as time goes on, becoming more noticeable in this deviation. So this is why we see that the red and the blue graph do not perfectly aligned on each other. Now let's answer some questions for the lab. So for our model system, is the energy principle justified? And I said yes, that the energy principle is satisfied because the gravitational potential energy represented in green decreases while the spring potential energy represented in red increases, and vice versa. As a result, the balancing of this energy makes the total energy equal to 0, which is represented by the orange line. This also confirms that there is no work being done by the surroundings, being that the system consists both of the spring, the mass, and the earth. Next, we have to compare the two estimates of the period of oscillation for both the y and x position. And I estimated that the period of oscillation for both the x and y by finding the average of 3 complete oscillations. This value shows that it takes roughly 0.4 seconds longer for the complete oscillation in the x direction than in the y direction. This shows that there is more motion in the y direction than in the x direction, which makes sense because there are more forces acting in the y direction, such as the spring and gravitational force, whereas the x direction only has a spring force. Thank you so much for learning physics with me, and I guess I will not see you next time. Bye!